Good evening. My name is Cesar Diaz, and I will be sharing my project number one, real world statics. My chosen structure. This structure can be found outside in the hall between Union East and Union West buildings. I mean, obviously in the University of Texas El Paso, and this structure was designed to support this kind of big umbrella, so the people that want to be outside the building, outside the union building, doesn't get too much exposed to the sun. Well, since I attend to the union building about 2 to 3 times a week to attend my job there, it could be considered that this structure is part of my daily life. Okay, so my knowns and unknowns. We don't have any known forces or loads, I mean, that we have before starting working and making the calculation. So everything must be calculated. And our unknowns are the support reactions AC and BC, which are kind of the support reactions from the floor to support the weight of the towers. Support reactions A, Y, and BY, which are the reactions that will oppose to the force of the wind. The weights of the components of both structures, the support reactions in structures A and B, which are the kind of the diagonal members that are supporting the structure. Those reactions, we will see that in a moment. The weight of the top bar that connects both towers, and the wind forces applied at structure A and B. Okay, so these are the free body diagrams for structure A and structure B. As you can see, there's a support reaction EC that, I mean, pushes up the structure. Same here with BC, the weight of the main column, the weight of the lateral beams, the weight of the supporting beams, these supports in both cases have the R the R reaction, which is the just kind of the reaction that creates the beam pushes down and tries to rotate, and these things contrast it a little. That's why they are there. And this will be the free body diagram for the lateral view of the structure. Assumptions. The structure is assumed to be made of steel with density of 7,850 kilograms per cubic meter. The floor support reactions RA and RB are equal between each other. The wind is supposed to flow from structure A to structure B, I mean, making this structure A to receive most of the wind load. The weight and possible aerodynamic effects of the umbrella are not counted for this analysis. And all the beams are hollow and have a thickness of 3 millimeters. These are the dimensions for the structures. Fusion 360 was used here because it makes it a lot more easier. This is the dimensions for the lateral V. Okay, so to determine the weight of the structure, it was just make the cross-sectional area of each of the beams, and then multiply it times the length and times the density of steel, which we saw in the previous slide, and with some other details regarding the geometry, but that's not very relevant. So for structure A, we have like main column 181 kilograms, LRs. The total weight of the structure found to be about 300 kilograms in both cases. Okay, so the support reactions A and RB, it was found that it couldn't be uh, good gotten from from the from the sum of forces in X, because all of them cancel each other. This one's up, this one's here, this one's here, this one was here, so it doesn't take you anywhere. The moments are symmetric, so that doesn't take you anywhere either. So it was thought that maybe the reactions could be gotten by taking kind of this approach of fixed support, but um, taking the forces sums on the C, it only leads to this support reaction here of these 500 newtons, and we could assume that maybe, well, if we don't take account this reaction support, this leads to this equation, but and we can take the sum of the moments, but this get us the it got some reaction at the moment, so we have two unknowns here, and we could assume that there's no moment generated, so we'll get a value for r. However, since that wouldn't happen, I mean that is not likely to happen in real life. The reaction A is found to be statically indeterminate, and same thing for B. Sum of forces for moments statically indeterminate. So, okay, the wind forces, um, it was found by doing a couple of research that the windiest day in El Paso ever recorded to be 84 miles per hour. And since we stated that the wind was flowing from structure A to structure B, and this is kind of like the structure is kind of like this, and if the wind flows, let's say like this, uh, part of structure A will cover a part of structure B. So this is why the wind is not impacted like in the whole structure B. Structure C, yeah, structure B. Um, so the area of structure A is found to be 4.108 meters squared, and the impactor area by the wind and structure B is this value, and these are the values for the wind loads. So we got the final lateral free body diagram with all the weights and reactions. Oh, these wind loads are applied at the geometrical area center for the wind loads. So this thing is up here because we don't consider the column, and this is kind of like the real mass center of the structure A. Okay, so finally solving for the all the remaining unknowns uh, for unknown forces, we get for the value at 3,425 newtons for the opposing force, about 100 for the opposing force structure B. This equation, and which we found the vertical reaction uh, structure B and structure A to these values here. Finally, we had as a final conclusion that the structure will remain under static equilibrium with the applied wind load, because we have no reasons to believe that the structure will not be able to provide these the necessary reaction components. So, because the structure is well attached and fixed to the floor and the concrete and everything. So the structure should be able to provide these necessary reaction supports. And it was calculated for without the wind load. The vertical components were about 2,000, 3,000 newtons in each of the structures. So a little more of reaction component on the structure B shouldn't make a difference on the static equilibrium state. So, okay, so that was presentation. Thank you for your attention.